Starting with a small introduction about my colleague Razan and myself. Razan heads the solution technical manager and the firewall operations within Monty Mobile, and I represent the deputy director of operation partnership. We are here today to present the flash call prevention solution, and we will start with a small brief and background about Monty Mobile. So, as you probably know, Monty Mobile has been in the market for more than 20 years in the telecommunication sector. We have a deep experience in the monetization of the international A2P SMS, as we have monetized this traffic for more than 35 operation in cooperation with our in-house developed solutions like the SMS firewall. We see a new threat on the A2P international monetization, which is the flash call bypass. This has been, tested and replicated in more than one country, where we saw the need to develop a solution to stop this and cooperate with the mobile operators to help them stop the impact on the A2P international SMS and still, protect the revenues from this stream.
So hello everyone, I will start by giving what is flash call and why it is considered as a threat. So currently the existing normal user behavior is when you request any type of verification code, when you download any type of application, you will go to the mobile application, you will put your B number and expecting you will receive an SMS with a code that you allow you to verify. Now, this is the default behavior, and usually mobile operators who monetize their international A2P traffic rely on this SMS business to generate revenues. Now, what we see currently is in the market a way to bypass the monetization, a way to send the verification another way than SMS. So the existing, currently the latest threat that we will cover in this innovation is how we can protect against flash call and how we can prevent flash calls to bypass the monetization of the mobile operators and to secure the mobile operators networks and revenue. So to start with, we have done our analysis in the market. We have studied what are the existing solutions. We even discussed with the mobile operators, our partners, what are their current capabilities in order to prevent or block such solution. Mainly based on our findings, all the existing solutions rely on analysis to block. So the flash call will pass, it will be terminated to the subscriber, and then analysis will be done to detect that this is a flash call, and then it will be blocked. Yet based on our experience in the market, this is not the best approach. The most effective approach to prevent flash calls is to prevent it in real time. And to achieve real-time prevention, this will have a direct impact on the conversion rate. We know that OTTs, mobile applications, all monitor the conversion rate in order to identify the route or the channel they want to verify their subscriber via with. And by conversion rate, we are referring to how many users requested the code versus how many users actually received the code. So as long as this conversion rate is high, the OTTs or the mobile application will keep using this channel, while as long as at any time they monitor a decrease in the conversion rate, they will switch back to the legit routes. And that's what we aim for, to block the flash call or prevent the flash call in real time, to force and to make the OTTs to switch and use only the legit channels of the mobile operators to secure the mobile operators' revenues and their strategy in their monetization of the international A2P traffic. Now, so we as Monty, we have solid experience in the monetization. So all teams from all relative departments, the testing team, the market analysis team, the business team, and even our developers and our technical engineers have started to brainstorm and come up with the best solution to prevent the flash call in real time. Now, in order to achieve this, we were considering two main factors. Now, in the end, in flash call verification or a missed call, it's just a normal missed call. Yes, it's true, it's zero rated and with no revenues to the mobile operator, yet it is a missed call. And usually, the default trends between users and between peer-to-peer, they do normal missed call between to each other. So the key factor to us in our solution, we don't want to impact any user behavior. We don't want to impact the normal trend and default trend of miscalling between normal users, yet we still want to achieve the blocking and the prevention in real time. So we have done a lot of testing, we have done a lot of market analysis, and we were able to identify that all the flash calls are terminated from international prefixes and predefined prefixes. We see different behavior in the market. We see in each region we see that a certain prefix is being used or a certain range is being used. Yet the focus now will be on the international ranges and predefined prefixes that are identified and proven to be selected or to be chosen to terminate OTTs or flash calls for OTT verification. Now, I will give just also another indication how flash call work in order to tell you how we best come up with the solution. Now, the flash call is a missed call verification. As I mentioned, that usually the default trend is for user. The expectation is he receive SMS, he receive a code, and he enter it in the mobile application. While this is not the case in the flash call will allow user to be automatically verified, and this will be depending on the handset of the user. If the user is Android handset, Android do allow mobile application to access the phone log of the user. They will identify that, yes, the A number they have initiated a missed call from or a flash call from is there in the phone log of the user, and automatically the user will be verified without any user intervention. While this is not the case in iOS handset, iOS do not allow mobile application to access the phone log of the user. Yet, as an alternative, there's a workaround for this. In the mobile application itself, they will guide the user to use the last 4 or 6 digits within the A number they have initiated a missed call from to enter it in the app, and accordingly, the user will be verified. Now, in both cases, the key indicator of the verification, whether the user is Android or whether the user is iOS user, is the A number itself. So we have done a lot of analysis to come up with 3 smart criteria, 3 smart mechanisms that will allow us to prevent the flash call in real time, not to impact the peer-to-peer normal missed call between peer-to-peer user, and yet at the same time have the key indicator in the 3 mechanisms will be the A number, as it's the only reason how the user will be verified. Now, option 1 or the mechanism 1 that we are proposing to our partners is mapping the data session of the mobile user with the receiving of international calls from international prefixes or predefined ranges. To give you an example, let's say based on our experience now, we know what are the apps that are using the flash call mechanism, what are the apps that are bypassing the SMS mechanism. So we have our analysis, our study, what are the apps, and we have the market experience in order to identify the IPs of these apps. So simply, whenever a user receives a call from a suspicious prefix or predefined range that was proven in our testing that it is used for flash call, we will identify from the data logs of the mobile operator if this user is logged into any of the apps that use such mechanism. So as long as we see a mapping between the data session of the user that he is logged into a mobile app that uses a flash call, and the user at the same time is receiving an international call from predefined prefix or international prefix that's also identified to be used for the flash call mechanism, this call will be blocked in real time. Now, this is one mechanism. Another mechanism, since in both cases the A number is the key indicator to verify the user, we simply can manipulate or mask the sender ID. This is again for the prefixes and for the ranges that have been identified to be selected or to be terminating flash calls from. Now, masking the sender ID will mean that if the user is Android, the mobile app will not be able to identify that the A number they have initiated a missed call from is there in the phone log, and thus the user will not be verified. And if his iOS have iOS handset, he will not be able to choose or enter the last 4 or 6 digits that he have been guided to enter from the A number they have initiated a missed call from. In this case, the call will not be blocked, yet the sender ID will be masked, allowing the user not to verify and allowing, of course, the conversion rate to be dropped. Now, a third mechanism is called thresholding, which is limiting the number of calls from the same number, especially international and predefined ranges, to be terminated to the user. And of course, here we will agree the first attempt on the number of thresholds. For example, we can block the first attempt of any call from international prefix or predefined range. And then if the same A number, assuming if this is a legit user, we will give him a busy note tone or unreachable tone. So if this is a legit user, he will attempt to call again. The second attempt will pass normally without any issues. Yet if this was really a flash call, the second attempt will be terminated from another A number, and this flash call will also be blocked. Similar case when we block any SMS. The first attempt of SMS, if it's via gray routes, will have a certain code, and the second attempt will have another code. So we are always trying to have the real-time blocking or prevention of the flash call verification in real time. This is to impact the conversion rate. This is to make sure that the OTTs or mobile application or whoever is using such mechanism will switch back to the legit routes, and we will ensure the monetization of the mobile operators and secure their revenues out of the monetization.
So, as Razan stated so far, the main benefits in terms of having a flash core solution implemented at the mobile operator side is to protect their network from this new type of leakage and to maintain the existing A2P international SMS revenues that they generate in case they monetize. In terms of the business models, we do offer this platform free of any charge to any operator who is already a partner of Monty Mobile based on exclusivity or preferential partnership on the A2P international SMS monetization. And on another option, we can also offer it as a standalone solution based on a CapEx or an OpEx model. After we study the topology of the network setup, we assess how the service has to be implemented, the solution has to be implemented, and the commercial offer will be decided on accordingly.
Now, how we come up with the solution? The solution, of course, as we started, that all our solutions are in-house developed. We customize the solution based on the market need. So teams of different departments were involved in this, and we are giving the mobile operators the flexibility to choose their preferred mechanism. We are in serious discussions with different mobile operators. The flash call is a new threat, but from our side, being an expert in the monetization market, we took a step forward. We took the initiative in order to have a solution ready for this, just in case at any time this flash call threat become the next threat and become the replacement of the SMS, which will not be in the favor of the mobile operators. So we are doing a lot of testing to our global partners. Each partner is different regions. We see different behavior globally, yet we are trying to unify the mechanisms in order to achieve one solution that will be applied to all the mobile operators. We are discussing with the mobile operators the prevention based on the three main mechanisms discussed. Each operator is sharing its preferred mechanism to be applied. Even some are combining two mechanisms with each other in order to achieve the best optimal solution. Now, since the system is in-house developed, we are being able to adapt to any technology the mobile operator prefer. We all know that the call routing overall have different setup. There are different call routing protocols ranging from Camel, ISAP, and including each mobile operator have its own network setup, its own topology. So we are in technical discussions how they can terminate the calls to the system, how we can intercept the call in best way in order to achieve the best deployment of the solution. Noting that for any preferred mechanism or topology the mobile operators or any of our partner prefers, we are ready to adapt accordingly. And of course, from our side, we have done intensive internal POC. We were able to achieve the effectiveness of the three criteria in order to prevent the flash call in real time. Now, what is next? It's all depend on the evolution of the flash call mechanism, whether the OTTs or mobile application will adapt to this technology or they will rely on that traditional or the rigid route, which is the SMS. Yet, from our side, we as Monty, we see that this is a threat. We see that this have direct impact on the monetization strategy that mobile operators apply. So we did not sit behind. We took a step forward. We took initiative, and the solution is there. We are in different discussion with our partners. We have different technical discussions based on their setup and based on their capabilities in the network, how we can deploy the solution. We understand there are 50-50 chances that the OTTs may adapt this mechanism in order to verify the solution, or they may not. But from our side, and since we are always on the side of the mobile operator, we want to make sure that the mobile operators are ready to secure their network, they are ready to secure their monetization revenue, and in order to ensure that their existing revenues from the monetization of the international A2P traffic is maintained.